Algebra 2, Unit 8, Day 3 notes. We're getting the fun stuff now. Okay, so now we're going to talk about a root of a formula here. Okay, if I give you an equation and I ask you for a root, okay, a root is a place where your y is going to equal 0. Okay, well, if you think about your graph, where does y equal 0? It equals 0 on any point on the x-axis. Okay, so a root is also an x-intercept. Okay, so here we're going to concentrate on the fact that a root is a solution or a zero. Those are what we're going to call roots. Okay, so if we look at the graph, we are going to graph your parabola. We're going to use the vertex like we've been doing, and we're going to do the 4 other points like we've been doing. Okay, we start with a vertex. Right 1, up or down. Right 2, up or down. Left 1, up or down. Left 2, up or down. Okay, so we're going to do all of that stuff still. Once we've graphed it, like this particular parabola, then we're going to find where the graph intersects the x-axis. Like, for example, this one here intersects the x-axis at 2 and at 0. So 2 and 0 are the roots, or 2 and 0 are the 2 x-coordinates that make y 0. Okay, so let's check it out here. We're going to graph this lovely parabola like we did in the previous notes. We're going to find the vertex. Step 1, let's find the vertex. Well, how do we do that? We're going to find the x-coordinate, which is going to be opposite of b over 2a. Don't forget that. Okay. So my a is 1, my b is positive 8, my c is 12. Okay, so opposite of b, so negative 8 over 2 times a, which is 2 times 1. So negative 8 over 2 is negative 4. Sweet. That's my x-coordinate. Now for my y-coordinate. My y-coordinate is going to be x squared plus 8x plus 12. Okay, now remember, we already know what x is for the vertex. So I'm going to put negative 4 where the x was. So let's go ahead and do some PEMDAS. Negative 4 squared is 16. Positive 8 times negative 4 is minus 32 plus 12. So the y-coordinate of my vertex, 16 minus 32 is negative 16 plus 12 is negative 4. Okay, that means that my vertex is the point negative 4, negative 4. Number so nice, we used it twice. Okay, so the vertex is negative 4, negative 4. So I'm going to go ahead and plot that right there. Okay, next step. We're going to graph the 4 other points. Okay, because we have this form that we've been working with, we can go from the vertex, right 1, up 1, left 1, up 1, right 2, up 4, left 2, up 4. Put the nice smooth curve through our points. And now we look at where the x-intercepts are. The x-intercepts are our roots. The roots are the solutions to your problem. Okay, so when does this equal 0? Well, the answer is, okay, at negative 2, 0 and at negative 6, 0. So x could be negative 2, or x could be negative 6. Those are both of my solutions. Okay, or we could just write x could equal negative 2 or negative 6. That would work too. Right? So we're just taking what we did in the previous day's notes, and we're just saying, oh, well, we can find roots from that. So we're not doing anything new other than just discovering where these zeros are. Okay, let's now go to finding the solution or roots of a quadratic. Okay, this is stuff that we touched on in 8F when we took the GCFs out. Okay, now we're just going to set it equal to 0, set our equation equal to 0, and we're going to solve for x. Right, so step 1 is always to take out any GCFs, always factor them out. Step 2 is going to be set each factor equal to 0. Because if I have two different things that multiply to give you 0, if either one is 0, that's a solution. Okay? So then solve for the variables. So here we go. So this one has already been factored out. They factored out a -5, and then they've got these two factors here. All right, so when they say take out any GCFs, they've already done it. They took out a -5. Okay. Second thing, set each factor equal to 0. All right, well, -5 can't equal 0. So what we would do is we would just divide both sides by -5. Okay? If we divide by -5, watch what happens. The only thing that happens is the -5 is gone. That's the only thing that happens. If I multiply -5 by something and I set it equal to 0, the -5 is inconsequential because -5 times 0 is still going to be 0. Okay, so here we go. Kind of like what we did in Unit 2, maybe a little of Unit 1 when we solve for absolute value. Okay, we are going to take each of these factors and split them. So y minus 1 could equal 0, and y plus 5 could equal 0. Okay, if y minus 1 is 0, then -5 times 0 is going to give you 0. If y plus, negative y, there's a negative y there. If -y plus 5 is 0, then obviously -5 times something times 0 is still going to give you 0. It's a good solution. Okay, so let's erase this guy. Let's get my negative back in here like they're supposed to. All right, so let's solve. Okay, let's solve both of these. I'm going to add 1. So y equals 1. There's one solution. -y plus 5 equals 0. So I can subtract 5 if you wanted to do that. Then divide both sides by -1. That's a -1, by the way. So I get y equals 5. So our solutions for example 1 are y can equal 1 or 5. Okay, y equals 1 or 5. Example number 2. Let's look at number 2 here. Now we have 1, 2, 3 factors. And because they all have x's, we're going to have to split this up to 3 solutions. See, this -2x, that could equal 0. This x minus 3, that could equal 0. This x plus 1, that could equal 0. Okay, so let's just solve them. It's algebra 1 time now. Divide by -2, divide by -2, and we get x equals 0 divided by -2, which is 0. So x equals 0 is one solution. I'm going to add 3, add 3. X equals 3 is also a solution. And then finally, subtract 1, x equals -1 is a solution. Okay. And guess what? If I put this in my calculator and graphed it, if I put it in the grapher, I would literally see those 3 roots like we had up here with these 2 roots. Okay. I would literally see the x-axis being intercepted at 0 and -1 and 3. Let's look at example 3. Okay, so now we actually have one that's not all factored out. So now we are going to factor out any GCFs. Is there a GCF here? Hopefully you can all see that 5x is a GCF. So if I divide the first term by 5x, I get x. If I divide the second term by 5x, I get -2. We have done step 1 beautifully. Step 2 says, set each factor equal to 0. Okay, so now I'm going to, let's swap the color up and take, the first factor was 5x. This 5x could be 0. This x minus 2, that could be 0. Okay, either one of those would give me solutions. So I divide by 5. X equals 0 is what a solution. I'm going to add 2. 2 is another solution. So if I graph this parabola, it would have x-intercepts at 0 and 2. They would be my solutions. Okay. Example 4. Do you see a GCF? I hope you do. There's a GCF here. For 4 and 24, 4 is a factor. For y squared and y is a factor. So 4y is my greatest common factor. Okay. So if I divide each of these factors by 4y, what do I get? Well, I get y plus 6. Okay. Wicked good. So now we're going to, okay, since we did step 1, we have the GCF taken out. We're now going to set each factor equal to 0 and solve. So 4y could equal 0. Y plus 6 could equal 0. Let's solve. Divide by 4. So 0 divided by 4 is 0. Subtract 6. 0 minus 6 is -6. My two solutions for example 4 are 0 and -6. Cool beans. So now we take 8f and we bring it into 8. Okay, sometimes we have to factor, which is what 8f was all about. If that is the case, we bring everything to one side so we get equals 0 on one side. Got to have equals 0. Then we're going to use all the stuff we did in 8f and we're going to factor it. And then we're going to do the steps that we just talked about. We're going to solve. Okay, so factoring. Okay, first off, is there equals 0? Yes. Okay, second, now we're going to try to factor and use our 8f skills. So, is there a GCF? No GCF. I'm just going to write over here no GCF so I remember that I didn't divide it out. Okay, there's no GCF. So now what am I going to do? I'm going to do product sum. So product sum. 1 times 9 is positive 9. It's positive 9. My B term, by the way, that's A and B and C. Don't forget them. Your B term, your sum is going to be -6. So I need two numbers, two factors, who multiply to give me positive 9, but have a sum of -6. Okay, so hopefully you can figure out that that's -3 minus 3. So -3 times -3 is positive 9. -3 plus -3 is -6, which is what we wanted. So I'm going to factor this, put my equals 0 at the end. So I've got u minus 3, u minus 3. Okay, fully factored. Okay, that's from 8f. Now, to bring you into 8, we are going to solve. So something times something equals 0. Well, each of those somethings could be 0. Okay. U could equal 3. U could equal 3. So the answer is U equals 3 is your solution. There's only one solution here. And if you graph this on your grapher, believe it or not, if you put it into Y1, you would find that the solution, the only time that the graph touches the x-axis is at 3 for x. Be kind of cool. Okay, so now this guy here. We've got the equal 0. Awesome. Equal 0, done. So let's see, factoring. Okay, is there a GCF? Well, we have a 1 here, so I don't see any GCFs. This one doesn't have an X, and the first one doesn't have anything other than a 1, so I'd say there's no GCF. So I'm not going to worry about GCF. But what I am going to do is I'm going to do product sum. Okay. So product sum, I'm going to find out A times C is negative 12. That's my product. My sum is positive 4. That's my B. So I need two numbers whose product, they multiply to negative 12, but they add to positive 4. So you could do 1 times 12. You're not going to get a positive 4 out of that. You could do 3 times 4, and you can't add or subtract a positive 4. But 2 times 6. Negative 2 times positive 6 gives me negative 12. Negative 2 plus negative 6 gives me positive 4. So that's a good one. So we're going to go x minus 2, x plus 6. Okay. So now we're going to, now that we've factored, we are going to solve. So x minus 2 equals 0, x plus 6 equals 0. Add 2. Subtract 6. So my two answers, my two solutions for example 6 are x equals 2 or negative 6. Okay. Couple left. All right. Example 7. Now, it does say we want to make sure there's an equal 0. There is an equal 0. Okay? It doesn't matter whether it's the right side or the left side. It really doesn't. If it makes you feel better, you can switch the sides. It's like saying 7 equals x, so x equals 7. If you want to change this so the quadratic is on the left and the equal 0 follows on the right, that's fine. It's the same thing. You're not going to change a thing. Okay? But if you just wanted to alter how it looks, you could do that. Okay, so step 1, there's an equal 0. Yippee. Cha-ching. Got it. Step 2, 8F skills. Let's factor. Well, look at this. There's an A that's a 4. Ooh, yeah. B and C. So remember, when the A is not 1 and we're factoring, we got to do the grouping method. Okay, so we're going to group. We still look for the product sum. It's just that this time, what we're going to do with the product sum is we're going to substitute it in for the plus 13x. Okay, remember that. That's why it's very important to do 8F, to do it well, to do it straight up and make sure that you understand it. Okay, so our product is going to be A times C. 4 times 3 is positive 12. The sum is going to be B, which is positive 13. Well, that's an easy one. I mean, what multiplies to 12 that adds to 13? Well, that's going to be positive 1 and positive 12. And that gives you the sum of positive 13. So what I'm going to do is I'm going to substitute for 13x. I'm going to substitute plus 1x plus 12x. Okay, so instead of the 13, we got 1 and 12. I'm going to bring down my 4x squared. I'm going to bring down my plus 3. And I'll bring down equals 0. Okay, I'll bring it all down. Okay, so again, going back to 8F, we're going to group. Here's a group, here's a group. GCF. The first group will always have a GCF that's not going to be 1. How do I know that? Because they both have x's. They always both have x's. So that means I'm going to at least have an x. Well, 4 and 1 don't have a common factor other than 1, so I'm just going to take the x out. I'm going to divide both of these terms by x. I divide 4x squared by x, I get 4x. I divide plus 1x by x, I get plus 1. Okay, so now what is the GCF of this second group? And remember, my second group must have the same expression in the parentheses. So my GCF, I'm going to have to divide 12x plus 3 and get 4x plus 1. Well, 12x divided by 3 is 4x. And it just happens to be the GCF, which is nice. So I divide 3 by 3, I get plus 1. I divide 12x by 3, I get positive 4x. Okay. Now, the last step that we had in our grouping was to factor out the last GCF. And the last GCF is what's ever in the parentheses. So if I take this and I factor it out of both of the groups, factor it out of the first group, I get x. Factor it out of the second group, I get plus 3. Bring down your equals 0. That's the only extra for 8 versus 8f. So now, last thing we need to do, okay, we've already factored. Now we got to solve. So we're going to split all the factors and say each of these factors could be zeros. They could equal 0. Okay, so now I'm going to subtract 1. Divide by 4, because the 4 is the coefficient of the x. So x is negative 1 over 4, and I can just leave it as that. If you want to put negative 0.25, it's a good answer. Okay, but negative 1/4 works, okay, and it's correct, right? So here I've got x equals negative 3. So my two solutions, for example, 7 are x equals negative 1/4 or x equals negative 3. Right? So we have one left. We have example 8. Example 8 is going to be our challenge question here because it's got all the stuff that we need here. We need to do all three of these these steps. So the first thing we need to make sure is we get an equals 0. This is the first time there was no 0 alone on one side of the equal sign. Okay, there's no 0 all by itself here. So what we're going to look at is getting equals 0. How are we going to get equals 0? What do we have to cancel? Well, on the left side of the equal sign, all that's there is a negative 30x. So I think what I want to do is I want to add 30x to both sides, because that will give me 0. Exactly what I want. Now, this is where you just need to be careful a little bit. If I'm adding 30x, if I'm adding, I need to add it to like terms. Is there another term that just has x? No. You can't add x to x squared, and you can't add x to a constant. So I'm going to keep the 30x separate. We want to have your x squared term, and then your x term, and then your constant, because you want to know what is A, what is B, what is C, in that order. So I'm going to put my 9x squared first. I'm going to put my plus 30x second. And I'm going to put my plus 25 third. That way I have my A, my B, my C. Okay. So first step is done. We got equals 0. Next thing we have to do is factor. Okay, here's the challenge. Again, the A is not 1, so we need to do grouping. And this is going to be a little bit bigger, but I guarantee you we can do this. All right, so here we go. Product sum. Okay, product is going to be 9 times 25. Okay, so if I have 9 quarters, what do I have? I have $2.25. So positive 225 My sum has got to be the middle term, which is 30. So like 1 and 225, I'm not going to add them to get 30. 5 and 45, I'm not going to add them to get 30. 9 and 25, I'm not going to add them to get 30. 225 is actually 15 times 15. So positive 15, positive 15. So if I replace 30x with positive 15x plus positive 15x, okay, that product is going to be 225, and that sum is going to be the 30. That's the main thing. The sum has to be 30. Okay, so let's bring down our 9x squared, bring down our plus 25. Don't forget to bring down your equals 0, because that's going to be, you know, the reminder for us to solve. Okay. All right. So this is grouping. I know this is multiple steps, but we can get this. Okay. So step 1, we got 0 on one side. Step 2, okay, we factor. We are factoring right now. So step 2 is a grouping method. It has to be grouping because that's not a 1. Okay, so we're grouping. What is the GCF of 9x squared and 15x? Well, for the x's, there's x. For 9 and 15, 3 is a factor that's common to both. Okay, so divide 9x squared by 3x, you get 3x. Divide 15x by 3x, you get plus 5. And we know that 3x plus 5 has got to be in the other set of parentheses. So that should help us a little bit. What's the GCF of 15x and 25? Well, it's 5. And if I multiply 5 times 3x, I get 15x. If I multiply 5 by 5, I get 25. Cool. So almost done on the factoring part here. So take the 3x plus 5s, factor them out of the two groups. And what's remaining? We got this 3x, and look at that, a plus 5. So we get a 3x and a plus 5 as the remaining factor after we factored out the 3x plus 5, which is the GCF factor. Okay. Last step. We factored, done. Now we are solving. Okay. Let's set each of these 3x plus 5 equal to 0. Okay. And yes, if I do one, I've done the other one, so I'm not gonna copy it twice here. So 3x equals -5. Divide by 3. So x is -5/3. And this one over here, you would get the same thing. Okay. So my answer is x is -5/3 is the only root, the only solution for example 8. Okay. Lots of steps. Go back, walk through those again. I invite you to do your practice and keep looking for more examples. Okay, hit that try another button and just keep working on more and more examples to give you practice. The more muscle memory you get in your brain, the easier this is going to get. So day 3 done. See ya.